All right, this is AP, AB, and BC Calculus. We are doing Unit 5, Section 1, which is using the mean value theorem. So let's jump right into the mean value theorem. So the mean value theorem states that if f of x is continuous on a closed interval from a to b, meaning including a and b, and f of x is differentiable on the open interval from a to b, so exclusive of a and b, then there is some c in that open interval from a to b, such that f of b minus f of a, all over b minus a, which would be old school slope between the two endpoints, is equal to f prime of c, which is the instant slope that we know how to find using differentiation. So essentially it's saying the old school algebra slope you learned is equal to the instantaneous calculus slope that you've learned. So let's go ahead and walk through this. Sometimes the mean value theorem doesn't apply, right? If f of x is not continuous, if there's a jump or a vertical asymptote or a hole, or if f of x is not differentiable, if there's a point or a cusp or a vertical tangent, then you can't apply the mean value theorem. So in most cases, in a free response problem, they're going to ask you specifically to say why the mean value theorem doesn't apply. Like that's often what will happen. Or they're going to say show that there's guaranteed to be a certain value. So usually they're setting you up to be aware that the mean value theorem is applicable or not, but it's hard to know. Okay. So given given f of x right here, show that there must be some c in 0, 3, the open interval, such that f prime of c rather is negative 2/3. So this is saying show that there must be, which is saying, hey, the MVT does apply. We just need you to sort of do the steps that will allow you to invoke the name of the MVT, and then there you go. So the first thing we have to do is we need to show why the MVT applies, right? So in order to show that the MVT applies, the first thing I need to show is that f of x is continuous, right? So f of x is continuous on this closed window from 0 to 3. And the answer is yes, because this is a cosine. So it's a graph that looks like this. There's nothing weird about it. It's going to go on forever. The second thing I need to show is that f of x is differentiable. Remember that if you're actually on the AP, you can't be lazy about writing out the word, right? It's differentiable on the open window from 0 to 3 for the same reason. You can picture what this graph looks like. It's just a cosine. So once I know that that part's true, I then need to check and see, so then I need to actually use the IVT and check and see that the average slope is going to be this negative 2/3. So I need to show that f of 3 minus f of 0 over 3 minus 0 equals f prime of c. So now I need to find f of 3 and f of 0. So f of 3 is cosine of 3 pi, which is a negative 1, right? Because 3 pi lives right here, right? 0 pi, 1 pi, 2 pi, 3 pi, that's a negative 1 cosine, right? And f of 0 would be cosine of 0, which is a 1 that lives right here on the unit circle, right? So I'm going to get that this is negative 1 minus 1 all over 3, which is a negative 2/3. So sure enough, by the MVT rather, by the MVT, yes, that's true, right? So I was able to show it by the MVT. So P1, you're going to go ahead and try the same concept with P1. I'm going to suggest that you pause me and try it by yourself. I'm just going to go ahead and walk through and do it. So first thing I'm going to do is I'm just going to kind of be lazy and say that this is a polynomial. And so it's always continuous and differentiable. And I could have said the same thing. For a cosine, right? The only time that a cosine is not differentiable and continuous is if you had inside the cosine something else that has a domain restriction, like the cosine of 1 over x. Well, 1 over x has its own set of problems. It's not the cosine causing the problem. So I can definitely use the MVT. Polynomial is always continuous and differentiable. So then I need to show that f of 5 minus f of 1 over 5 minus 1 is equal to f prime of c. So I really need to find f of 5 and f of 1. There's a couple different ways to do that. F of 5 is not super fun. So you can either find f of 5 by straight up plugging in, right? 5 cubed would be $1.25, right? Minus 2 times the 25, so that'd be minus a 50, right? Minus an 8 times a 5, which would be minus a 40, right? And then minus a 10. So it seems to me that I get that this whole thing is a 125 minus a 100, which should be a 25, right? So that's f of 5, right? And when I plug in f of 1, I seem to get 1 minus 2 minus 8 minus 10, right? Which seems to be a negative 19, right? So I get that this is 25 plus a 19, right, minus a negative 19 over 4, right, which seems to be 44 over 4, which is 11. Sure enough, by the MVT, yes, this thing they asked me to show is totally true, okay? So let's keep moving on. All right, so a particle moves along the x-axis such that its position is given by the twice differentiable function x of t. Okay, so this is important information, and we're going to talk about why in a second, okay? Because you're going to have to justify that the MVT applies. Select values of x and t if given in the table below. Show that there must be some time between 0 and 7 such that v of t equals 1. Well, the reason this is an MVT question, this show that there must be some time is definitely a theorem. Whenever you hear show that there must be some value, show that there must be some time, that's going to be a theorem. It's going to be the IVT or the EVT or the MVT. It's going to be a theorem, right? So the trick here is to recognize that v of t equals 1 is the same thing as saying x prime of t equals 1, right? So this is saying that the instant slope, right, so the instant slope of x of t, right, has to be the same. So this is the mean value theorem. Now, in order to show that the mean value theorem applies, right, I know that x of t is differentiable, which implies continuity. Right, so I know, and not only is it differentiable, but it's twice differentiable, which is good to know. But because it's differentiable, it implies continuity, so I can definitely do the mean value theorem. I then need to show that x of 7 minus x of 0 over 7 minus 0 is going to equal x prime of some c or t value. Like you could just, you know, it's up to you if you want to find. You can call it c, you can call it t, it doesn't really matter. All right, so when I do this, I'm going to get that this is a 6 minus a negative 1 over a 7, right? That's a 7 over 7, which is a 1. So sure enough, x prime of some value c in that window, right, in 0, 7, has to equal 1. So sure enough, just an MVT question. They just didn't ask you for it. But when you see this, like, show that there must be some, that's usually a theorem question, so stop and think which of these theorems could be applied here. If it's a theorem that involves finding the derivative at some point is equal to some average slope, that's going to be the mean value theorem. All right, so you go ahead and pause me if you want and try P2. It's going to be the same idea. Okay, so particle moves along the x-axis such that its velocity, hey, that's not how you spell velocity. Velocity, oops, is given by the differentiable function, so it matters that v is differentiable, right? Select values of v of t are in the table below. Show that there must be some time such that a of t, which again is worth noting that that's v prime of t. This is a mean value theorem question. So show that there must be is definitely a hint that you're using a theorem, right? So I'm showing that v prime of t is 7/5, which means, so I have to say why the MVT applies, right? So the MVT applies because v of t is differentiable. You can't be differentiable unless you're continuous. So that implies continuity. So you have to state that. You have to, if it's a free response, you have to openly explain why you're allowed to use the MVT. Then I show that according to the MVT, v of, the window they gave me was 5 to 30. So v of 30 minus v of 5 over 30 minus 5, right, should equal v prime of t, right? And notice I made that connection. I said, hey, a of t is v prime, right? You have to do that for some value. And again, if you just want to call it t, you can. If you want to call it c, that's fine. So this is going to be a 65 minus a 30 over a 25, right? Which should be a 35 over 25. Cancel a 5 out of that, and you get a 7/5. So sure enough, v prime of t, which is a of t, right, has to equal 7/5 at some point in that window. And actually, I should go back up to the example real quick. You should make sure that you answer the question the way they asked it. So they asked to show that v of t has to equal 1. You should say, oh, okay, cool. That means v of c is 1 at some point, or v of t is 1. You should make sure you link it back to the function that they're asking about. So again, here they specifically asked for a of t. So although I did the math understanding that a of t is v prime, and I communicated that clearly right here, I should make sure that I throw that in as my final answer. All right, moving on. Find the c value guaranteed by the mean value theorem on the interval or state why the mean value theorem doesn't apply. Okay, so in order for the mean value theorem not to apply, right, this doesn't apply if your function is either not continuous or not differentiable. Well, that's not going to be an issue here because this is a polynomial, right? Polynomials are like the happy, well-adjusted children of the function world. There's nothing wrong with them. So a polynomial is always continuous and differentiable. That's not how you spell differentiable. Differentiable, right? So a polynomial is allowed, so MVT always applies, right? So the MVT applies for a polynomial always, right? So this is fine. I can definitely apply the MVT, but I have to state that explicitly. I have to say this is why I know I'm allowed to do this. So I need to find y of 4, right? So I need to do y of 4 minus y of 0 over 4 minus 0. So I'm going to have to find those two values, and that's going to equal y prime of x or dy dx at some point in 0, 4. And you could call it y prime of x or y prime of c, where c is the number in 0, 4. That's fine. So let's go ahead and find those two values. So y of 0 is easy. It's a -3, right? Because it's 0 plus 0 minus 3. But y of 4 is a little bit more of a pain. So y of 4 is going to be a -64 plus a 64. Oh, hey, that was nice. Minus a 3. That works out really well, actually. I just get another -3. So I get -3 minus a -3 over 4 equals y prime of x, right? So I'm going to get 0 equals my derivative, right? Well, since you were asked to find the c value, right, and you could, again, if you want to call this c, you can, right? I really need a formula for y prime. So I know that y is negative x cubed plus 4x squared minus 3. So that means my y prime is going to be a -3x squared plus an 8x. So I need these two things to be equal, right? My y prime has to equal 0. So I set them equal and I say, cool, 0 equals this y prime. I'm going to factor out a -x and be left with 3x minus 8. So either 0 equals -x, which gives me x is 0, and we'll talk about that in a sec, or 0 equals 3x minus 8, which is going to give us x equals 8/3. So the trick is that this is not in the open interval from 0 to 4. Remember, the mean value theorem doesn't include the two endpoints in the solution window, so my only answer is 8/3. 8/3 is in the window between 0 and 4. If neither of these answers had been in the window, then the MVT would not be working for some reason, and I would need to go back and figure out what's up. So again, when you give the answer to the MVT, you have to give the answer in the open interval, not the closed interval from 0 to 4. Okay, so let's go ahead and try this one. So again, you can see that, so pause me if you want, but you can see that this is a polynomial, right? So a polynomial is always continuous and differentiable. So I can definitely use the MVT. Right, so what that means when I say that is, hey, cool, I'm good to use the MVT. Okay, so the MVT applies. Then what I have to do is find the average slope and find the instant slope. So it's up to you. If you want to go ahead and find your y prime right now, you can. You're going to get a -x plus 1, right? So once I go ahead and find y prime, I need to show that the old school slope, right? So old school slope equals the instant slope. That's what we're showing with the MVT, right? Old school slope equals instant slope. So the old school slope is going to be y of 1 minus y of -2 over a 1 minus a -2, right? So when you plug in, and it's up to you where you find these values, right? So I'm just going to try and squeeze in and find y of 1 up here, right? Y of 1 is going to be -1/2 plus 1 minus 1/2, which seems to be 0, right? Y of -2 seems to be a negative, and then this will be a 4/2, right? So -2 plus another -2 minus a 1/2, right? Double check my math on that. Seems to be right, right? So I seem to get that this is a -4.5 or a -9/2, whichever one you like better, right? Doesn't matter to me. So what seems to happen here is I seem to get that this is a 0 minus a -9/2 divided by a 3, which should be a 9/2 divided by 3. You can either make that 9/6, or you can recognize that it simplifies to 3/2. I need that thing, so this whole thing, is going to equal my instant slope, which is negative x plus 1. When I subtract the 1 over, I get 1/2 equals negative x. So I think I get x equals negative 1/2, which sure enough falls in that interval. So this is the c value that I get, right? So this is, and if you want to, since they said c value, if you want to say c is negative 1/2, that's certainly fine as well. Cool. All right. Find the c value guaranteed by the mean value theorem, or state why the MVT doesn't apply. Okay, so this function does have a discontinuity, right? So this graph has a vertical asymptote when 4x equals 0, but that would be at x equals 0. It is worth noting that that is not in the interval. That's the only discontinuity this has. So y is continuous on the window from 1 to 3. Unfortunately, to figure out if y is differentiable on the window from 1 to 3, you kind of have to differentiate and see if you end up with a problem on the bottom. So I'm going to go ahead and find what y prime is using the quotient rule. So I'm going to get low, d high, minus high. Oh, I lied. That's silly. Hang on. Y is going to be differentiable, and I'm going to show you why, but only because my brain is slow and it's early and there's not enough coffee. So y is differentiable on the window from 1 to 3. The reason I know that is, think about it this way. When I do the quotient rule, the bottom of the quotient rule is low squared, right? So high, d low. The bottom is still going to be the same thing, just squared, right? So if 0 was the only number that was a problem on the bottom originally, it's also going to be the only number that's a problem in the quotient rule, right? Because that's how quotient rules work. So the bottom is low squared. Whatever the low was, if that was the problem before, it's going to be the same problem. So I needed y prime anyway, so it doesn't hurt. So this is a negative 8x squared. This will end up being a plus 4x squared minus a 36. So I end up getting that this is a negative 4x squared minus 36 all over 4x quantity squared. Cool. So this is my derivative, right? So once I know that this stuff is true, right, I can see that the only issue, 0 is an issue for both continuity and differentiability, but it's not in the interval I was given. So MVT does apply, but again, I need to expressly state that I can use the MVT. So then when I go to use the MVT, I need to find that y of 3 minus y of 1 over 3 minus 1 is equal to the thing I just found y prime to be. And you can call it y prime of c or y prime of x, it doesn't matter. The point is that you don't know that x coordinate right now. So when I plug in, I'm just going to go ahead and give myself a little bit of room to find y of 3, right? Y of 3 is going to be a 0 because it's negative 9 plus 9 over a 12, so it's a 0, right? Y of 1 is going to be an 8 on top of a 4, which is a 2. Sorry, I got a little bit scrambled. So 8 on top of 4, which is 2. So I'm going to get that this is 0 minus a 2 over a 2, which should be a negative 1. That negative 1 is supposed to equal this ugly monstrosity that is my y prime. Cool. So let's finish this guy out. So let's see if we can get this to work out so that we can see it. There we go. Okay, so now what we're going to do is we're going to say that this negative 1 equals a negative 4x squared minus 36 all over a 16x squared, right? It's up to you if you want to factor out a 4 and cancel. It's not the worst idea on the planet, certainly. Or you can just multiply the 16x squared over. Negative 16x squared equals negative 4x squared minus 36. Right, I'm going to go ahead and add this 4x squared over, so I'm going to get negative 12x squared equals negative 36, right? So I'm going to get that x squared equals 3, right? Which means x is plus or minus the square root of 3, but remember that I have to be in the window from 1 to 3. So if you look at this answer, right, so here's 1 and here's 3, right? Square root of 3 is like 1.7-ish. This is root 3. And this is negative root 3, right? Negative root 3. You can see that if I'm in this window, the only answer is root 3. So root 3 is the answer to the MVT. That's the C value guaranteed by the mean value theorem, and that was not a short problem. Cool. Let's go to the next one. All right, so P4, same idea. Again, you're going to have to look and see if there's an issue, if there's a value where you have essentially a discontinuity, and there is, right? So here, you're going to have a vertical asymptote where 2x minus 4 is 0, which is going to be at x equals 2. But that's okay because it's not in the interval, right? So this graph is not always continuous, but y is continuous. And you're going to see in a second, sorry, continuous as a u there, and it's going to be differentiable. So it's going to be continuous and differentiable essentially for all x except x cannot be a 2, which is what we see right here, right? So since 2 is not in the interval, we're legit, MVT applies, right? Now, if this window had gone up to, let's say, 3, then this wouldn't have worked, right? So yes, I can do the MVT, right? So I need both y of those two values, and I need to find y prime. I don't care which one you do where, right? So I'm going to go ahead and find y of 1, which is going to be 1 over a negative 2, right? I'm going to find y of negative 4, which is going to be a 16 over a negative 12. Yes. This is one of those times that it's kind of worth simplifying to make your own personal life easier. I can cancel it. Maybe it's not, because I'm going to need to get everybody over an even number anyway. You can simplify if you want. It's up to you. You can leave it as negative 16 twelfths if you want. So my old school slope, right? If I want my old school slope, it's going to be negative 1/2 minus a negative, so that'll be plus a 16 over 12, right? All divided by a 1 minus a negative 4. And this alone is enough for people to not love this problem, right? I get that. If I want to get a common denominator here, this is a negative 6/12. So I'm going to get negative 6/12 plus 16/12 all over what seems to be a 5, right? So my old school slope seems to be a 10/12 all over 5, right? Or a 5/6 all over 5, which is going to either be a 5/6 times a 1/5, if that's easier, or you can realize that it's just a 1/6 because you have 5 of the 6, and then you're dividing it in fifths. So that's my old school slope, right? And then my derivative, so if we go back up for a sec, right? My derivative, y prime is going to be low, right? So low d high minus high d low. Draw the line and square the low. And again, you'll see that with this quotient rule, the reason I didn't have to worry too much about this being differentiable is I can see that the denominator is the same factor as the denominator of the original. So on top, I get that this is a 4x squared, right, minus an 8x minus a 2x squared. So I think I get 2x squared minus 8x all over this thing, which we're going to deal with in a sec. So we're going to go ahead and set this thing, as ugly as it is. So now, to use the MVT, I'm going to say that the old school slope, 1/6, is equal to 2x squared minus 8x over this 2x minus 4 quantity squared. Yeah, okay. So I'm going to cross multiply and get 2x minus 4 quantity squared equals a 6 times this ugly binomial, right? I'm going to need to FOIL this out. Please don't just try to make both of these terms squared. That's not how squaring a binomial works. I almost made that a 14 because it's, again, early and there's not enough coffee. When I oh, interesting side note, if you really wanted, you could take a GCF of 2 out of both of these and it would make the problem a lot easier, but it's up to you. If you see that this is actually a 2 times an x minus 2 whole quantity squared, you could have a 4 out in front and it makes your life a lot easier. It doesn't matter to me which one you do, but if you do this, it's a little bit easier to FOIL, and also because all of the things on this side are multiples of 4, you could make your life a lot easier. It doesn't matter to me. So let's say I don't spot that. I would FOIL and get 4x squared. Outside is a minus 8x, inside is also a minus 8x, and last is a plus 16. I'm going to move everybody to one side to solve. I'm going to go ahead and move everybody to this side. So 0 equals, I'm going to get an 8x squared when I subtract the 4x squared over. When I add the 16, I should get a minus 32x and then a minus 16, right? When I yank out an 8 GCF, which will make my life a lot nicer, I get this. Oh, that's fun. So after all of this work, that is not something that factors. So this is prime, which is just mean. So you're going to have to use the quadratic formula. You know that 0 does not equal 8. That's a lie. So you want when 0 equals x squared minus 4x minus 2. So that's going to be at x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's going to be a 4 plus or minus 16 plus 8 should be a 24. So it's a root 24 all over 2. I can keep simplifying here. I'm going to get that this has a 4 times a 6, right? So this is going to be a 4 plus or minus 2 root 6 all over 2, which means my two answers are 2 plus or minus root 6, right? So 2 plus root 6, 2 minus root 6. And then after all that, so then you have to figure out which of these two answers is feasible based on your region. Well, the region you were given was -1 or -4 to 1, right? So after all of this, I have to ask myself, which of these is in the, open interval from -4 to 1, right? Because that's what I have to pick. So when I go to pick my answer, it's really helpful to picture what 2 plus, or so think about root 6, right? So you don't have to know what number root 6 is, but you do need to know that it's smaller than root 9, which would be a 3, and that it's bigger than root 4, which would be a 2. So this is 2-point stuff, okay? So the reason that's relevant is that if you're trying to figure out which one of these answers is in the range that you're looking at, 2 plus 2-ish is going to be like a 4, right? So if you realize this, right, if you realize this information, then 2 plus root 6 is going to be 4-point stuff, right, which is a technical term, right? And 2 minus root 6 is going to be negative point stuff, right? Like it's going to be, because it's 2 minus 2 point something, so it's going to be negative point stuff. So this one's in the interval, but this one's not, because 4-point stuff is not in the interval that we're talking about. So my answer is only x equals 2 minus root 6. There's a minus there. That's the only answer. And not the other one. And that's tricky when you get something that's a quadratic formula, especially in a non-calculator section, but it can happen, which is why I made examples that involve that. All right. Find the C guaranteed by the mean value theorem, or state why it does not. The mean value theorem doesn't apply. So if you picture what x to the 2/3 looks like, right? So first off, this is continuous, because remember that essentially discontinuities mean that the denominator of something is 0. And there is no denominator here. So there's no denom. So this must be continuous. So y is continuous on, again, on an AP Calc test, you should do the solid upstanding citizen thing of writing the entire word. Continuous on this window, right? But it's not going to be differentiable, because if you try differentiating this, you're going to get 2/3 x to the -1/3. Suddenly you have something in the denominator, right? So now there's a denominator. This thing is going to have a problem when 3x to the 1/3 is 0, which is at x equals 0, which is in the window, right? So y is not differentiable at x equals 0, right? So the MVT does not apply. And that's it, right? But you have to justify why the MVT doesn't apply. Now, you could have graphed this, and if you graph it, what you're going to find is that the graph essentially looks like this. So this is what y equals x to the 2/3 looks like, and this is that sharp edge, right? This is a cusp. So remember, sharp edges, like sharp pointy edges, sharp point / edge in a graph means that it's not differentiable. So that's actually why, like if you were to graph it, if you know what the graph looks like, you could explain that at x equals 0 there is a sharp edge. The other way to do it is to actually differentiate and show that there is a problem. So again, not f of x, y is not differentiable, so the MVT doesn't apply. All right, last one. So same idea, right? So this thing has a vertical asymptote when 4x plus 8 equals 0, which is when 4x equals -8, which is when x equals -2, which totally falls in this interval. So y is not continuous on this interval because of a vertical asymptote at x equals -2, meaning that the MVT does not apply. So the reason that you need to check and see that the MVT applies before you say anything else, or before you do any math, is because if it doesn't apply, number one, you're getting points for explaining why it doesn't apply, and also you can stop once you say that it doesn't apply. The other reason you need to check anyway is because on a problem where it does apply, you are definitely getting points for applying it. Now, if it's a multiple choice question, and they ask you what value is guaranteed by the mean value theorem or something akin to that, and then none of the 5 answers say this doesn't apply, well, then you can assume it applies, because if it's multiple choice and they gave you 5 answers and all of them are actual numerical answers, then it must apply, and you can just kind of blow past that step. But if you're ever actually doing this problem where you have to work it out, or where one of the choices says that the MVT does not apply, you need to be mindful and pay attention to that.